Welcome to part two. And in part two, we're going over probably the most important piece in the unit and probably overlooked as well, the front pump. And this is where all your pressure comes from. And pressure is a very, very important part of an automatic transmission. Before we get into it, let's talk about some of the failure points. In the last video, we talked about the case. And it's very rare to have a failure point other than an orifice or a check ball and maybe a driveline problem if you blow the whole fucking back out of the case. And trust me, if you blow the back out, that's all it's ever going to be. Drive shaft, U-joints, follow it back. The pump is a very big leading cause of failure due to lack of pressure usually. Some of the things that will cause low pressure due to a pump is a bad pump build itself. O-rings are not replaced, slide is wrong size, converter spacing, faulty flex plate, things like that tend to collide in here, and it doesn't like that very much. Steel and aluminum are not good friends at high speeds. The infamous 1870 TCC PWM type codes, this is part of that circuit, and this valve is a big player in that. This is the TCC apply valve. For the guys at home, Sonex does make one with a Teflon seal, and it usually seals up that worn out bore from days long gone. Because don't forget, guys, these are 30 years old now. They are, we need to start fixing stuff rather than just slinging parts at it. Really, some of the only other things that could happen to your pump is a converter shits itself all over the place, blows the lockup clutch, and clogs the screen up, really inhibiting main flow. Doing damage to the face and back. And stuck PR valve, either in or out, can cause low or high pressure depending on its position. So those are really some of the more simple things that can happen to your pump. And the main symptom overall in all those explanations is going to be, I have extremely low pressure, or my pressure is not where it ought to be. On a stock unit, we are talking about 60 pounds at idle and about 160 PSI maximum at wide open throttle on a stock unit. Most built units like us at PerformaBuilt, we do an average of 220 wide open throttle, and we try to still keep it 60 to 80 at idle. Moving on to the build. As I said before, bushings are done, everything's cleaned and inspected. On inspection, before we get to building our pump, the areas where things turn and ride on each other in a transmission is really the primary focus. A transmission has journals just like an engine. So this isn't technically a journal, but it is a surface where your rotor rides, okay? This thing can never see load. So this surface here must be free of gouges. You will see marks on it, especially if you are trying to repair this at home. Marks are okay. That's not what's detrimental here. You need to feel any gouges, any scratches. You need to correct that at a local machine shop, or if you have your own equipment like us can. The back, same deal. This section right here is where the rotor rides. It needs to be nice and smooth. There will be a rotor pattern on a rebuildable unit. Most people like us lathe this. I'm doing it like you guys would today. This one is in excellent shape. It's very smooth. I couldn't ask for a more perfect pump out of a unit. Some of the other things we want to look at, make sure your orifices are plugged, or not plugged, I mean, especially this TCC apply circuit. This orifice powers this whole valve, and it's extremely tiny. That is essential for lockup and making it work right. If this is clogged, you may not have lockup. Some of the other things to check are the back half of this, and namely in the stator, okay? The stator sleeve must be smooth and in good condition. It is technically a journal, and these two journals as well on the back of the stator, right here. These must be smooth. They must be in good shape, and feel free to blow some air through your stator or use a parts washer with mineral spirits to check for flow as well. This should not be clogged. All the fluid comes from your pump and goes to where it needs to go. Building a pump is very simple. You want to inspect, clean, all that good jazz. And the biggest thing you want to do before you get to building your pump is do your bushing and do your seal on a shop press. You can use your bushing driver and hammer set, but this I highly recommend the shop press for. It's your converter. It's going to spin a lot. It weighs a lot. You're expecting a lot out of these 3 bushings. Building a pump, we always start with the slide. You can build back to front, front to back, it don't matter. This O-ring is essential in your slide. And you cannot usually mix match slides. There are different sizes. You want to check the surface in here. It should be a nice bluish gray hue. This one is very, very new. Looks like it has like 10 miles on it. We want to keep our finger under that ring and O-ring. Drop it in. Be gentle, be dainty. Next, we want to do our Teflon and rubber on our slide. They call these the wipers. The Teflon wiper will come in your rebuild kit. Most of the time they don't see a lot of wear and you can reuse them. However, the black rubber should be replaced every single time. They tend to get flat and they do not last near as long as the Teflon. We want rubber side in, Teflon out. We don't want the rubber rubbing or wiping, as they would call it. We want the Teflon wiping. And that orientation has to be just like that. The next piece to lock that in would be the slide pin and spring. Now the slide pin is a wear item. Usually there is a land here and the slide itself. And right here you can see the, I picked this because you can see the motion. And this one's great because right here you would feel a ridge, but there is none. But you could see where it would happen. This is in very good shape, will last for many, many, many miles. So don't be scared to reuse your pin. If there is a pretty deep gouge out of it from overall wear, let's say 300,000 miles, these are readily available. You should replace it. You want to squeeze that rubber and Teflon together and drop in your spring and pin. It should slide just so. And a great way to check the slide, which I don't have a razor blade on me at the moment, but this is where your mic comes in. Your slide against the face should be a little higher than the face, and we're talking by 1,000th. But you should see light, and we do. You can also clearly feel it. That is correct. Your O-ring is in there, it's pushing it up, and that face is going to compress it, and that's going to give you some good pressure. The next thing I like to do is the rotor. Now, this only goes in one way. It's got your rotor guard teeth here, your rotor guide, and that only goes in one way as well. And you see that's the wrong way. So it's either or, but it just sets in there. You want to pay attention to here. Now this is a new rotor, but in here, as in my previous videos, this is where we can see where your old spacing was or if your flex plate over flexing. Something to pay attention for, especially if you've broken your pump and that's why you're rebuilding your unit. So, rotors don't break by themselves. I've said it 1,000 times. I'm saying it again. We're going to put our ring in here. This is just what I find easiest. Mic fell off. Just a consequence here. That's what I found easiest. Then we take our finger, thumb, and we lay that washer right in the center of that ring. At this point in time, we take our vanes. Now these are not cheap, believe it or not. Most of them are in pretty good shape, especially if you've taken good care of your unit. These are fantastic. They're almost new. I do suggest replacing them if they have seen a lot of miles. Now, all we're going to do is slide these down in there. They should go in very, very easily. If they're not going in easily, you may be contacting that ring down below, or your rotor might really not be straight and in good shape because cast can still warp, and that's what these are made out of. Tip from me to everyone is if you are having trouble with your bottom ring down there, take like your little screwdriver or a pick and very gently just move it along, but you can usually do that with your vanes. Now, I'm using a 13 vane rotor. I find those to be the best. It's my preference. Some guys really like to use 10. It's like the Ford and Chevy argument. They'll say it's stronger and this and that. It may be, but it's not enough to really, really matter. So don't overcomplicate this, and that's the biggest lesson I could teach you about building transmissions. Don't make it too complicated, and please don't listen to what everybody says. The last thing next to our little ring, and you can tell you've done everything right, as this actually ought to be a little bit of a pain to get in. And there should be a tiny bit of play, but it should be fairly tight. The last thing we want to do is our spring. There are a little bit better ones out there. I like to use the ones from the 4L65 and 70. They're conical and single. If you have a double spring, which most of you will, it's perfectly fine for a daily driver and mild performance application. These, in my opinion, I use these in well over 1,000 horsepower, and they've done me good. So how I do this is with your flathead, medium size that I like, and I push it up against my belly. I push the slide back, and I use the flat part, and just my thumb ease her in there. It should be buttery smooth, and if you're new, this thing may actually fly up and hit you in the face, but that's okay. Keep trying, and be persistent. You'll get good at it someday. To help prime this thing, a 4L80 and 400, they're gear driven. These are very different pumps. 4L80, 400, they have no room for error, and they need grease. These are vane type pumps, 204R, 700R4, 6L80. These 4L60 like we're working on today, same type of pump. 13 vanes, even in your 6L. We want to throw some tranny oil in there. That's all we want to do. And it should be very nice. Minimal noise, very smooth, and the fluid should come up. We're done with our pump face. We're going to set that aside, and we're going to move on to the backing. Now the backing, this is where your valve train comes in the pump. And we have 3 different types of valve. You got your boost valve, you got your PR valve, and you got your TCC apply valve. Those I talked about a little earlier. The TCC apply, no use modding it. You can put a better sealing one in there. That's your preference. It'll have a double or a single spring that sits in the cup. I have an earlier style valve, and for your guys' reference, the nipple goes on the springs, which, try to do this backwards and clearly for you all for camera's sake, goes in just like that. Okay. Then we're going to take our little retainer and our snap ring clip. And this, you got to forgive me because there's no way I'm that coordinated to, but it's a fairly simple process. There we go. And it's going to go pretty far down in there. Okay, so it goes down about 1/2 inch. It is a little bit of a pain, as most snap rings are, and it should seat right in the groove when you get it there, all by itself. You should barely be able to see it. That's how you know you're in the groove. One thing to check, take your little screwdriver through that hole and stroke the valve. Ours does move. Now, going on to the PR valve. That's the other side. We simply install the PR valve like this. Just drop it in there and give it a wiggle and help it down, and it should just drop into place. Okay. Then we take our 2 springs. We have our center spring, and that should go onto the nipple of the valve. Then we have our outer spring. I usually slide these in a little differently, but for camera's sake, I'm trying to do it so you guys can see it. Okay, I think we all can see that small spring inside the big one on the nipple. Now here is a modification that you are more than welcome to do, and it is only healthy for your unit. We have our boost valves. This is the stock one that came out of the pump backing. It's a little scratched up. It's definitely seen a little fluid erosion, and it's one of the decent ones. It's not huge, but it's not the smallest. There are a fairly cheap option, a little bit bigger boost valves to install in your transmission. This one here is a 490. I think this will be great, and that's what I'm going to put in today. It is a nice, tight, brand new boost valve. I believe you should replace the boost valve, as it is just cheap insurance, because this is your pressure. So that we just slide in, nipple side down. You are welcome to grease this up, but it should go in easily all by itself. And there will be spring tension, okay? I'll try to do this for you guys so you can see to the best of my ability here. We put our larger snap ring in, squeeze, and give a firm push down. And we are fully seated. Now, one test to do is it should, about an 1/8 inch or so, it should push back and forth. But that's how you know you have it done right. And the only other thing we have to do, a commonly forgot part, is our pump screen. This catches all your converter debris and anything else you might not want inside your rotor vane combo here. And that just simply slides in and pops right in. All we have left is to make the two halves, and there is lining up the pump, which is a very important detail, but we're actually going to move that to the assembly section because it's much easier to show and do, and that's when you guys would do it anyway. But for now, the trick to mating your halves together is have a hole somewhere and pick a spot. The spot I like to use is the square right here. So we have a square right here. And all we're going to do is match the squares. And your bolt holes are your bolt holes. They're going to they can't move in any way, so this is really only going to fit one way anyway. And we're going to thread these in, set it aside, and move on to part 3 of our video, which is the next piece of the input drum. This is where the speed handle kind of comes into play. Kind of makes it easier. Most people are gonna jump the gun and ask me why I'm not using an impact right now. You definitely don't want to at the moment. There's more to do, and you don't want the bolts tight for lining up the pump. But we want them secure just so what we've just built doesn't spill out when we go to set this thing aside. And there you have it. We have a very well put together pump, probably capable of about 180 psi, which is just a little bit higher for a good application of a daily driver, towing vehicle, or a general mild street rod. And it's going to be very consistent. We're nice and flat. Valves have been checked. Next thing, we're going to do the piece that plugs right into it, the input drum. Join us for part 3.